Hi, and thanks very much for your interest in biological engineering at Purdue University. I'm Dr. Kurt Ristroph. I'm an assistant professor in the Department of Agricultural and Biological Engineering here. I have with me three excellent student ambassadors who represent our department. So we'll go through introductions first and then get into what our department does and what our undergraduates study. So I teach ABE 201, which is Material and Energy Balances in Biological Systems. It's the first sophomore level course in our biological engineering curriculum. And I'm co-teaching Chemical Engineering 320, which is a statistical analysis class. My research lab works on developing nanoparticles and scalable nanoformulations for both agrochemical technology and for nanomedical applications. Up next, we have Kayla Hinton.
Hello everyone, my name is Kayla Hinton and I am a senior here in biological engineering. One of my favorite classes that I have taken so far has been ABE 307, which is Momentum Transfer in Food and Biological Systems. I really enjoyed this class because it was one of the first times where I felt like what I was learning was relevant to what I would apply in the real world and in my actual engineering career. Some of my campus involvements: I am the second vice president of the National Association of Colored Women's Clubs here on campus. We are just trying to foster an inclusive environment for colored women here at Purdue. I am also the secretary for Alpha Epsilon, which is the honor society for ag and bioengineers, and I am also the treasurer for ABE Ambassadors. Some things that I have done in my past: I have studied abroad in Germany, learning about industrial microbial technologies with an ABE professor. I highly recommend going on either that trip or a different study abroad trip while you're here at Purdue. Another thing, I did research at Procter & Gamble. I was a beauty R&D hair care intern, and so that was really fun, learning about the consumer goods industry and learning about just industry in general and what it is like to work an actual job. And after graduation, I will be continuing my journey in the consumer goods field and be working in a supply chain rotational program at Clorox in Atlanta, Georgia.
Hello, my name is Jora Pugliese. I am a junior in biological engineering. My favorite class in ABE so far has been ABE 201, which is Material and Energy Balances in Biological Systems. I loved this class because of the hands-on lab experience that I got. It was taught by Dr. Kurt Ristroph, who is an amazing teacher, and I loved having the opportunity to design my own novel food product with a group in the lab. Some of my campus involvements involve Chi Omega sorority. I'm the alumni relations chair. I'm also the treasurer for the Purdue Beekeeping Club, and I competed in the soybean innovation competition. Some of my internship and research experiences include my corporate QA internship at Red Gold Tomatoes this past summer, and my study abroad in Valencia, Spain after my sophomore year. I loved this study abroad. It was a great opportunity to get to know the ABE staff and learn more about food production in Spain. My future plans post-graduation: I hope to enter the food and beverage industry and eventually open my own winery. But for now, this summer, I am taking on a quality leadership development internship at Buffalo Trace Distillery for Sazerac Company in Louisville, Kentucky.
Hi, my name's Ellie Tanner. I'm a senior in biological engineering, and my favorite class in ABE was ABE 370, which is where we focus on things like how drugs break down in the body and how we can use math to model different enzymatic reactions that take place in food and pharmaceutical processes. So moving on from just ABE, I am also involved on campus as a part of the Women's Water Polo Club, as well as the College of Engineering Ambassadors Program. I am also formerly the president of the American Society of Agricultural and Biological Engineers within the department. So that's going to be our professional society for students. And then I have also done a lot of research, both in the ABE department and at Purdue BME, where I was focused on biomaterials for regenerative medicine. And I also was able to do a summer program at the University of Pennsylvania doing research on mechanobiology. In the future, I plan to start my career at Eli Lilly after I graduate in May, where I will be on the manufacturing and quality team. Before we get into the fine details, here's a little video about what it's like to be a student in ABE.
This is you. Yeah, you. You want to solve problems, make the world better. You're really into the details. Really into the details. You have mad math skills, science too. You're not afraid of technology. You know what else is you? You want to know how things work right down to the cellular level, whether it's a cell in a bioreactor or tissue in your body. We know you, and we know where you need to be. Biological engineering. Biological engineers know what renewable fuels, clean water, and insulin have in common. They use biology, chemistry, physics. And they solve problems, not just at the cellular level, at the global level, and everything in between. You can join them, make a difference, apply solutions, discover. We know where you need to be, and you could do it all at the #1 biological engineering program in the country. Curious? Talk to us.
All right, so what is biological engineering? We say that the field of biological engineering is using the tools of life to improve lives. Because if you think about it, the Industrial Revolution is only about 250 or 300 years old, and evolution and life have been going on and figuring out how to make molecules for hundreds of millions of years, right? So we can make a lot of things with the bulk chemical industry. There are things that the bulk chemical industry can't make. There are things that we have to use cells to make. These are things like enzymes, like peptides, proteins, nucleic acids, right? So biological engineers are the ones who work at that intersection of process engineering to make something at a large scale and biology, where you are using these bioreactors or cells or tissues, for example. And the field really got started around actually the production of penicillin during the Second World War, which is one of these biologically produced antibiotics that has to be grown in a bioreactor rather than being commercially synthesized in a reaction vessel. Okay, so biological engineers, like I said, they work at the intersection of processes and biology. So our biological engineers work on a number of different applications of these biological processes. For example, the manufacture, production, and purification of pharmaceuticals or biopharmaceuticals. For example, we have a professor in our department who works on the directed evolution of enzymes for making at lower temperatures and more benign temperatures and pressures and processing conditions complicated molecules as an alternative to the bulk chemical industry. We have people who work on biofuels. We have people who work on the environmental aspect of what you can use these biological tools for in the environment, measuring things and controlling and engineering things from an environmental standpoint. All right, many of our alumni go on to work in those industries. They work in pharmaceuticals, they work in nutraceuticals, they work in personal care, they work in biochemistry, they work in environmental consulting or government consulting or food production, of course, is a big one. I think I already mentioned personal care. And then also biofuel production and the energy sector and the environmental sector.
Okay, so what are the areas of focus that we have here in ABE? So we have 4 main focus areas that includes cellular and biomolecular engineering, food and biological process engineering, pharmaceutical process engineering, and bioenvironmental engineering. And in these focus areas, some of the courses that you will take will be basic engineering courses that all engineers take, such as heat and fluid transport, mathematics, mechanics, thermodynamics, as well as ABE specific courses like biology, bioenergy, biochemistry, physical, and life sciences. And with these courses, we hope that you build tools that will allow you to be able to computate and model complex biological systems, genotyping, phenotyping, protein processing, biomaterials, or anything that you set your mind to, really.
You may be wondering, what can you do with a degree in biological engineering? Here are some of the industry sectors that a lot of our graduates go into. Some of those sectors include consumer goods and services, such as nutrient supplements and other biological-based goods, energy, oil, and gas, like bioenergy, food and beverage production, which involves food process engineering, scale-up and development of products, healthcare, pharmaceuticals, and medical devices, similar to BME, but this focuses on more of the living cell cultures and fermentation, research and development, and formulation. And finally, renewables and the environment. Additionally, our graduates do continue on into research in synthetic biology applications, scale-up, bioprocess research and development, enzymes, and more, and continue on to professional schools like dental, medical school, and vet school. Some of the careers and companies that you may encounter with a biological engineering degree. A lot of our graduates go on to become bioprocess engineers, biotechnology engineers, biomaterials engineers, food engineers, genetics, and so much more within the pharmaceutical and the medical field. Some potential companies that a lot of our graduates have worked for include Campbell's, Kraft, Mars, Cargill, Pfizer, Kellogg's, General Mills, ADM, Merck, and so many more.
Now, here at Purdue, ABE is much more than just your major, it's also your community. So let's talk a little bit about the ABE student experience. First and foremost, we have been ranked #1 in the country for this major for over a decade now, and as a result, we have had 99% placement for our students in either jobs or graduate school after they graduate from our department, and we also have great numbers of scholarships that can be given to students, so that's extraordinary as well. Pretty much everyone who I know that has applied for these scholarships has been able to get some funding. So that's just another great way the department looks out for us as students. But also beyond just those numbers, we also have great facilities that are brand new. So we have a brand new building that you can see on the slide that was just built and finished in about 2020. So we are really enjoying that. And we are also able to have very individualized attention from faculty in this new building, especially because we are all sharing the space together. So additionally, kind of to look more closely at our student to faculty ratio, that's going to be 12:1, which means we have very, very small classes. You build really deep connections with not only your classmates, but also your professors and TAs within this department. That really makes it feel like a family, so that's something that's more rare at such a big engineering school. As a result of this very small student to faculty ratio, we also are all assigned to a faculty mentor as students within the department. So my faculty mentor, for instance, also led the trip to Germany that I went on, and I had her for class. So I was really able to build a deep connection with her. And this is true for many students, so that also helps us to be more involved in student organizations and clubs that those professors lead, as well as getting research and internship experience through our connections with those faculty members. So some of the organizations that we do have through the department are going to be, first and foremost, ABE ambassadors. That's us. That's the people who are here kind of talking about the department to you guys. We also have ASABE, which is the professional society that I was president of for a couple of years. And through that society, we are able to provide workshops to build professional skills for undergraduates while also building community, helping you to meet upperclassmen who can kind of lead you through your time here. And we also do lots of industry tours and kind of bring in reps from different companies to help you hopefully get an internship or a full-time career. We also have Alpha Epsilon and Alpha Mu, which are honorary societies for seniors within the department. And finally, we have Purdue EYM, which stands for the International Genetically Engineered Machine. And that is going to be a competition where they work on things like COVID tests or treatments for celiac disease, for example. So they do really cool stuff, and they do a lot of lab work and travel as well. But that's really just the tip of the iceberg. There are also lots more societies and clubs that ABEs are present in on campus. These are just a few examples, including the Society for Chemical Engineers, AKE, or PSEF here on campus, and PESC, and even SWE for those of us who are women engineers. We actually have right now the highest percentage of women engineers across all Purdue engineering majors, which is really great. Thank you so much for sticking with us through this entire video. We really appreciate your interest in the department. If you have any questions, we're going to have our contact information here at the end so that you can reach out and learn more. But one of the most common questions that we do get at EYMs is asking what the difference is between BME and BE. So as a BE who has done a lot of research in BME departments, both at Purdue and different universities, I would say that the difference is that BME is more focused on basically like mechanical engineering with an application to biosystems. So that would be like prosthetics or imaging, whereas BE, our department, is more focused on sort of chemical engineering with an application to biosystems. So that would be more of working with fermentation tanks and different microbes to kind of go through a process and get something at the end that we're looking for. So I'll pass the mic to Dr. Ristroph to talk about the difference between chemical engineering and BE.
Thanks very much, Ellie. So I'd say the second most common question we get is what's the difference between BE and ChemE? So here the disciplines are very, very close. And I always tell people, okay, if mechanical engineering and electrical engineering are cousin disciplines, chemical engineering and biological engineering are sibling disciplines. They're closer than that. And biological engineering is the younger sibling by a little bit from chemical engineering. And so the tools we use are largely similar, right? Where you have a focus on process development and process scale up, things like that. Many of our biological engineering faculty, including me, have one or more degrees in chemical engineering. You see reciprocity between our classes, right? I'm co-teaching a chemical engineering class that all of our biological engineering students take. So there is a lot of overlap between the two disciplines. We are on, of course, very good terms with the chemical engineering department. They're our friends. We work together. I would say the main distinction is in the application of all those tools that we're learning and using at the same time, right? So classically, chemical engineering is focused on paper, plastic, and petroleum production, and biological engineering, I would say, is focused on pharmaceuticals, food, and fuel or biofuels, for example. So some of the applications are a little bit different, but the tools are very, very similar.
Thanks so much again for listening, and we are excited to answer any additional questions you have. Bye-bye.
Cheers.